Hello everyone and welcome to our fourth 9 weeks chapter 11 review. And so this is going to be on area and surface area and volume. Remember that all of these formulas will be supplied that are on the formula sheet. So it says in the first set of directions, solve for the area, round the nearest tenth. So I'm going to make a note of that. Round the nearest tenth if necessary. And so what is the first shape? The first thing I want to do is acknowledge that I have a solid black line. And that creates a three-sided figure, and we know that that is going to be a triangle. So what is the formula for the area of a triangle? We'd go to our formula sheet, or we just know it in our heads. It's going to be base times height divided by 2. And so when I look for my base height combo, we know that there are technically 3 bases on a triangle. Right now I only have 2 listed, the 8 and the 12, but we know that there are actually 3. What I'm looking for is a base height combo that are perpendicular. So I find this right angle. And then there is my base in this solid black line. I don't include the dotted part because that is outside of the shape. That is just showing that it corresponds to this height, which is going to be 6.7. So 6.7 is my height that corresponds to this blue base. And so my area is going to be equal to 8 times 6.7 divided by 2. So I do not even need the 12 for this problem. I could have a height if I had a perpendicular distance right here. That would be a height, but since I don't have it, I'm going to have to work with a 6.7 and the 8. So 6.7 times 8 divided by 2 is going to give me 26.8. What are my units? Since this is a triangle, that is going to be inches squared. Whenever you have area, it is always going to be units to the second power. All right, a parallelogram is a little bit easier. What color did I? Okay, I did yellow. All right, so 4 solid black lines. It does tell me it's a parallelogram, thankfully. And so we'd go get our formula, which says the area is equal to its base times its height. So again, we want to get our base height combo that is listed. Technically, we have 4 bases, 2 of which are matching. We have 2 sets that are matching. But the ones that are going to be perpendicular to each other are this 6.7 and this height that is exterior. And so I've got my base here and my height. Again, that's a dotted black line, so I don't include it. And so that's going to be area equals the base, 6.7, times my height, which is 6.1. So 6.7 times 6.1 is going to give me about, when I round it, about 40.9. And again, my units are going to be squared, so meters squared of area on the shape. All right, now in this problem, this is not a parallelogram because we don't have both opposite sets being parallel. I have one opposite set that's parallel, and I've got the corresponding height between it. So I've got 2 bases that are parallel, different sizes, and I've got a height. So what shape is this? This is going to be a trapezoid, so you did have to recognize that on this problem. And I've got my legs are non-congruent, and so a trapezoid formula is going to be base 1 plus base 2. So this is like a triangle that got its head chopped off. That's just like chopped off. And so I've got 2 bases times the height divided by 2. And so I'm going to add those together. That's going to be 10.3 plus 4.7. I multiply that by my height, which is the perpendicular distance between these two, and I divide by 2. So I'm going to type this in. My bases added together gives me a total of 15 times 7 divided by 2, and I'm going to have 52.5 yards squared of area exactly. All right, number 4. Now, number 4, we talked about this in class. This one's not on your formula sheet. If I gave you a regular polygon, so this is a regular polygon. We really would need to be told that from the beginning in the directions where all the sides are congruent. 1, 2, 3, 4, 5, 6. And so I'd tell you as a regular polygon, and it'd also give you the formula if I gave you a problem like this, but it's you've got your apothem times your perimeter divided by 2. And so what is your apothem? Your apothem is going to be your this perpendicular distance to the center. And so my apothem is going to be 14. And then I'm going to multiply that by my perimeter. Well, what is the perimeter? I've got 16.2 all the way around. I always think of SpongeBob SquarePants when he says bring it around town. So my perimeter is going to be calculated, I'm going to do this right here, by doing 16.2 times 6. Well, what is 16.2 times 6? I'd have a perimeter of 97.2. I'm going to multiply that by my apothem and divide by 2. So times 14 divided by 2. And I'm going to get 680.4. It doesn't have units here, so we're just going to put units squared. All right, and then what shape is our next shape? Well, the first thing I notice, some people might think it's a parallelogram, but these opposite sides are not congruent and they're not parallel. But I do have this set that are congruent, and then I do have this set that are congruent. So that makes this a kite. The diagonals in a kite are perpendicular to each other. So we know that we have right angles, 4 right angles here. And we know that we can find the area of a kite by doing diagonal 1 times diagonal 2 divided by 2. Well, how do I find diagonal 1? We talk about those in class. We talked about like those like fancy toothpicks that you get whenever you're sampling something. And so if I've got a fancy toothpick that has a piece that's 12 and then a piece that's 8, how long would you put on the flag to say how long that fancy toothpick is? Well, what is 12 plus 8? 12 plus 8 is going to give me 20. And so we want to do that same thing for this other portion, this red diagonal. But the problem is that we don't have either of the pieces. So I do know that I can use Pythagorean theorem to find what each of these pieces is. Since it's a kite, those are going to be congruent. So 1, 2, 3, 1, 2, 3. So I'm going to use Pythagorean theorem and say x squared plus 12 squared equals 13 squared. So that's a Pythagorean triple. You could do 13 squared minus 12 squared. You get x squared equals 25. And so if x squared is 25, what is x? It's going to be the square root of 25. So x is going to be equal to 5. This is also a very common Pythagorean triple. So if 3, 4, 5 is the most famous Pythagorean triple, that's like the Taylor Swift of all triangles. A 5, 12, 13 is like the Travis Kelce triangle. It is still popular, still well known, but you know, Taylor put him on the map. So if that's 5 and that's 5, that's going to give us 10. And so now we've got 20 times 10 as our other diagonal, because 5 plus 5, and we're going to divide that by 2. So of course that's going to be 200 divided by 2, which is going to give me 100. There's no units, so we'll just put units squared of area. So we did have to find a piece of our diagonal for the red one and double it, since in a kite, those are going to be, that short diagonal is going to be bisected by the long diagonal. All right, for a rhombus, it's the same formula. They told us it's a rhombus, so d1 times d2 divided by 2. So let's use our diagonals and let's put our fancy flags on them. Since this is a rhombus, I know that a rhombus the diagonals get bisected. So if that's 17, this is 17, and that diagonal, that flag would be 34. And then in yellow, this piece is 11. And so if that piece is 11, this piece is 11. So what goes on that fancy flag? Well, 11 plus 11 is going to give me 22. So I would do 34 times 22 divided by 2. So I think about it like the fancy flag on a toothpick. So that's going to be 34 times 22 divided by 2. That should give me 374. What are my units? That's going to be feet squared of area. All right, so that's area. Solving for the area. Area is always in units squared. All right, now it says given the similar figures below. So the first thing I'm going to do is make a note. It does tell me that they're similar. Identify the similarity ratio, perimeter ratio, I'm supposed to say ratio, and area ratio. All right, so here's for number 7. Similarity ratio is always going to be the same as the perimeter ratio. So both of those are going to be A over B. Those should be the same. What is the area ratio going to be? It's always going to be A squared over B squared. So how do you find your similarity ratio? Well, if the first one, or the perimeter ratio, if the first one has a perimeter of 27, the second one has a perimeter of 27, then A over B, I guess I should start with that. A over B is going to be equal to 27 over 36. Let's reduce that fraction. If it does, let's see, 27 over 36. Use your calculator. That is 3/4. So my similarity ratio is 3/4. The first shape is 3/4 the size of the second shape. My perimeter ratio is 3/4. The perimeter of the first shape is 3/4 the second shape. And the area ratio is going to be 3 squared over 4 squared. Well, what is 3 squared? 3 times 3 is 9. 4 times 4 is 16. And there is my area ratio. Same thing on the next problem, except instead of starting with their A over B, they start with their A squared over their B squared. So they make you work backwards. So if my area of the first figure is 144, that's my A squared. What is my B squared? That's going to be equal to 225. We want to reduce that. If it does, I don't think it does, but let's see. Oh, maybe it does. It does. That's going to be 16 over 25. So I'll fill that in for A squared over B squared. That just helps me not have to reduce it over and over and over again when I get my answer. So if that is A squared over B squared, how do I get my similarity ratio? Well, that's going to be the square root of 16 over the square root of 25, because I want to go from something that's squared to something that's not. So that's going to be 4 over 5, which means that the perimeter ratio is also going to be 4 over 5. So this was 16 over 25. Very, very similar when we get to the bottom when we talk about similarity, surface area, and volume. It's going to be A over B a squared over b squared for surface area. Volume, we just throw in a third component, which is a cubed over b cubed. So we'll get back to that in a minute. All right, the next set of directions says, solve for the surface area and volume of each figure for prisms and pyramids, round to the nearest tenth. So the ones that do not have a pi in the formula. For cylinders, cones, and spheres, leave in terms of pi. So for our set of directions, it essentially is telling you if it has a pi in the formula, leave it in terms of pi. If it doesn't, then round to the nearest tenth. So what is our, first of all, let's name this shape. This is a cylinder. And so that's going to help us get our formulas. Surface area of a cylinder is going to be, you could always scroll and get this if you need to, but it's going to be, you have two bases and then you have the height, the circumference and the height. So that's going to be 2 pi RH plus 2 pi r squared. You won't have to memorize that. I'm supplying the formulas. So I need my radius, which I don't have currently. My radius is going to be half of 12, which of course is going to be 6 miles. This is a really big cylinder. This is further than I can run. 6 miles. I can't even do the diameter is 12. The radius is 6. And so what is our height? Well, you'll remember I like to color code. I'm the queen of color coding. And so there is a base. There is a base. I think I did blue just to be consistent. Hold on. There we go. So this is a base. This is a base. This was my radius, halfway across. And then my height was going to be the capital H, the distance between the bases, which is going to be 8 miles. And so we're just going to plug that in. That is going to be surface area equals 2 pi 6 squared times my height, which is 8, plus 2 pi 6 squared. That was horrible handwriting. Hold on, 2 pi 6 squared. I'm a math major, so I have to write a good pi. Whenever I write a sketchy pi, I have to always redo it. Okay, so I'm just going to type this in. 2 times 6 squared times 8 is going to be 576. So I've got to make my math teachers proud. 576 pi plus, now we type in the other part, 2 times 6 squared. It's going to give me 72 pi. And so whenever I leave this in terms of pi, I just add those together for my surface area. 72 plus 576 pi is going to give me a total of 648 pi. Surface area is always going to be to the second power. Volume, I'm going to go ahead and fill this in so I don't forget, is always to the third power. So what is my volume formula? My volume formula is just going to be its base times its height, which is going to be pi r squared h. Okay, so that's going to be pi times 6 squared times my height, which is 8. So I'm going to type in 6 squared times 8. That gives me 288 pi miles cubed for my volume. All right, number 10. What shape is number 10? Number 10 is going to be a cone. And so for the surface area formula, we're going to have pi RL plus 1 base, which is going to be pi r squared. So we just need our radius. Our radius, of course, is going to be 5 yards because it's going to be halfway across this diameter. And so I'm going to cross out that 10 so I don't use it again. And then we need our slanted height. Well, do we have our slanted height? We do not. We have this value, which is going to be my interior height. So that's going to be 10. I'm going to scribble it out and put that right here, 10 yards. We're going to need our slanted height in a minute. And so, of course, we're going to find that using our Pythagorean theorem in a minute. And that's going to give me my slanted height, which is also going to be L. And so we're going to use that in a second. So let's go ahead and actually calculate that. That is going to be 5 squared plus 10 squared equals L squared. That's going to be 25 plus 100, which is going to be the square root of 25. I'm sorry, the square root of 125. And so we're going to leave that as the square root of 125 until I am ready to round. So it's going to be pi times 5 times the square root of 125 plus pi times 5 squared. So 5 times root 125 is about 55.9, and I'm going to add 25 pi to that. That is going to give me about 80.9 pi yards squared of surface area. Volume of a cone is going to be base times height divided by 3, which is pi r squared times my height divided by 3. Volume equals pi 5 squared, oh y'all, that's a horrible pi, times my internal height, which is 10 from just the height of the cone divided by 3. So of course 5 squared times 10 should give me 250, and then a third of that is going to give me 83.3 repeating. You can do that as a decimal, or You can turn that into a fraction. If you turn that into a fraction, it'd be 250 over 3. So there is my volume of that cone. Spheres, this is like a ball, like a basketball. It's called a sphere, S-P-H-E-R-E. Surface area is going to be equal to 4 pi r squared. And then volume is going to be equal to 4 pi r cubed divided by 3. So let's go ahead and fill in what we need. We need our radius. Well, my radius is going to be half of 21, which is going to be 10.5 centimeters. I'm going to cross that out when I'm done with it. And so it's going to be 4 times pi times 10.5 squared. My volume is going to be 4 times pi times 10.5 cubed over 3. So let's type both of those in. 4 times 10.5 squared is going to give me 5. Let's see. And my radius is 10.5. So 4 times 10.5 squared is going to give me 441 pi centimeters squared for surface area. 4 times 10.5 raised to the third power divided by 3 is going to give me 1543.5 pi centimeters cubed of volume. And y'all, I've got a little bit more than I want left. I'm going to have to go video 2. I'm so sorry. Tune in for the next video.